Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. In this video, we are still in a discrete probability. So the topic that I want to discuss is subtopic 2.3, independent event, and also subtopic 2.4, conditional probability, Bayes theorem. Here are the objective for the two subtopic. Okay, for subtopic 2.3 for independent event, the objective is I want everybody must know how to find the probability of independent events. While for subtopic 2.4 conditional probability for Bayes theorem, at the end of the lesson, I want everybody must know how to find the conditional probability for events and also soft probability using Bayes theorem. Okay, so let's start with the introduction first. So this is a chart for theory of probability. So we have two types. The first one is independence probability, and the second one is a conditional probability. Okay, so let's go to the independence probability first. Under independence probability, we have independent and also dependent. Okay, so for independence probability, two events A and B are independent if and only if we can show that probability A intersect with B is equal to multiplication for PA times PB. Okay, so we call it is an independent probability. If the two events are not independent, so oppositely we call it as a dependent. Okay, so this is for independence probability. So how about conditional probability? Okay, conditional probability, if A and B are any two events in a sample space S and probability A is not equal to 0, so the conditional probability of B given A, so this one, probability B given A is equal to probability A intersects B divided by probability A. So this is for conditional probability. Okay, we are going to find probability B given A. So under conditional probability, we have a Bayes theorem. So what is a Bayes theorem? Bayes theorem connects conditional probabilities to their inverse. Okay, for conditional, we are going to find probability B given A. But for Bayes theorem, inverse. That means we are going to find probability A given B. Alright, so this is about Bayes theorem. So if B1, B2 until Bk constitute a partition of the sample space S and PBI, probability for Bi is not equal to 0. For I equal to 1 until K, so then for any event A in S, such that probability A is not equal to 0, so we will use this formula. So this is formula for Bayes theorem. And actually, we can transform the problem by using a tree diagram. Okay, so this is a tree diagram of Bayes theorem. So if you can see, we have a B1 until Bk. Okay, B1, B2 until Bk. So we can find the probability for B1, B2 until Bk also. And then after B1, we have A. So this one is called is PA given B1. Okay, how about this one? The second A, this is called PA given B2. Okay, until BA. Okay, so how to find PA intersect with B1? So PA intersect with B1 is equal to PB1. This is PB1 multiply with probability A given B1. Okay, so you can apply this one, okay, into our tree diagram. So now we are going to find the inverse. Let's say P B1 given A. So how to find this one? Okay, we can find by using this theorem. Okay, so let's try example here. So we have let A and B be independent events. So PA is equal to 0.7 and probability B is equal to 0.2. Okay, so the first one, we need to compute PA intersect with B. We need to compute PA union B. And the last one, we are going to compute P complement A union complement B. So, the question already told us that this is an independent event. Independent event means PA intersect with B is equal to PA multiplied with PB. Alright, so for number one, okay, so this is easy. You are going to find probability A intersect with B. So by using the formula PA multiplied with PB. So you will have PA 0.7 multiplied with 0.2, you will have 0.14. Alright, how about how to find number two, PA union B. So actually we already know the formula. A union B is equal to what? Probability A plus probability B minus with probability A intersect with B. So PA 0.7 plus PB 0.2 and we already calculate PA intersect B. Okay, that means we are need to minus 0.14. So the answer is 0.76. Alright, so how about the last one? We are going to find probability for A prime union B prime. Okay, actually we just use this formula also, but we just change A to A prime. So we will have PA prime plus PB prime minus PA prime intersect with B prime. Okay, so how to find PA prime? So PA prime is equal to what? 1 minus PA plus PB. PB is equal to what? 1 minus PB. This is for PB prime. Okay, and how to calculate PA prime intersect with B prime? That means we are going to find PA prime multiplied with PB prime. Okay, so we already know PA is equal to 0.7. So 1 minus PA is equal to 0.3. Plus, we also know PB is equal to 0.2. So 1 minus PB, that means 0.8. Then minus PA prime times PB prime. So this is answer for PA prime 0.3 and then multiply with PB prime 0.8. So the answer for number 3 is 0.86. Now let's try for this example. A balanced dice is tossed twice. If A is the event that an even number comes up on the first toss, B is the event that an even number comes up on the second toss, and C is the event that both tosses result in the same number. So the events A, B, C are pairwise independent, and the second one independent. Okay. Let's list out all the outcomes that we have. Okay, for event A, that means even number come up on the first toast. Okay, so that means we have everything in terms of 2. We have 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And then another one we have 4. For 1, for 2, for 3, for 4, for 5, and also for 6. And the last one we have for 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and also 6, 6. Okay, so this is the outcome for event A, where total is, we have 18. Okay, total we have 18. Okay, how about event B? Event B, the even number comes up on the second toast. That means we will have 1, 2, 1, 4, 1, 5, 1, no, no, not 1, 5, 1, 6. Okay, and then we have 2, 2, 2, 4, 2, 6. Also, we have 3, 2, 3, 4, and 3, 6. We have 4, 2, 4, 4, 4, 6. The next one, we have 5, 2, 5, 5, 4, 5, 6, and lastly we have 6, 2, 6, 4, and also 6, 6. So total for event B, we have 18 also. And for the event C, okay, both tosses result in the same number. That's mean for C, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and also 6. Okay, so we know independence. Independence, that's mean PA intersect with B is equal to PA multiply with PB. Okay, so the question asks you to find pairwise independence. Okay, pairwise independence, that means we are going to check PA intersect B is equal to PA times PB. We're also going to check PA intersect C is equal to PA multiply with PC. And the last one, we are going to check PB intersect C is equal to PB multiply with PC. Okay, so let's check PA intersect B. Okay, A intersect B. So what we have, okay, okay, so let's check for PA intersect B. This is A, this is B. So what are the same thing between PA and PB? So we have 2, 2 here, 2, 2. And then we have 2, 4 and 2, 6, 2, 4, 2, 6, 2, 4, 2, 6. Okay, and then we have 4, 2, 4, 4, and 4, 6, right? We have 4, 2, 4, 4, 4, 6. Here also we have 4, 2, 4, 4, 4, 6. And also we have 6, 2, 6, 4, 6, 6. This one we have 6, 2, 6, 4, 6, 6. Okay, that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9. So we have 9 over 36. Okay, 9 over 36 is equal to what? So we have 1 over 4. Okay, this one, is it equal to PA times PB? So what is the probability for PA? Okay, probability for PA is equal to 18 over 36 is equal to 1 over 2. Okay, and then probability for B. Okay, probability for B is equal to 18 over 36 is equal to 1 over 2. And probability for C. Okay, this one total C is a 6. So probability for C, PC is equal to 6 over 36. So I will have 1 over 6 here. Okay, so let's check. PA multiply with PB. So PA is equal to 1 over 2. PB is equal to 1 over 2. So this is 1 over 4. Okay, so for A intersect B is equal to PA times PB. Okay, how about PA intersect with C? Okay, let's check. A and C. We have 2, 2, 4, 4, 6, 6 only. Okay, we have 2, 2, 4, 4, and 6, 6 only. Okay, we don't have 1, 1, we don't have 3, 3, we don't have 5, 5. Okay, that's mean P. A intersect with C is equal to 3 over 36 is equal to 1 over 12. Okay, how about PA times PB? PA times PC. PA times PC. So is equal to PA we have 1 over 2. PC is equal to 1 over 6. Okay, so we have 1 over 12. So the same thing. So this is for PA intersect C. Okay, so I hope you can check for PB intersect with C is equal to PB times PC. So the answer for PB, for the last one, this is the answer is 1 over 12. Okay, make sure you check. So for number one, this PA intersect B intersect C, A intersect C, and PB intersect C. This one we call it as a pairwise independence. Okay. So how about number three? Okay, independent. Okay, number one is sit pairwise. That means what we call a combination for two event A and B, A and C, B and C. But this one we call the sit independence only. That means you are going to check PA intersect B intersect C is equal to PA times PB times PC. Okay, so now let's check. Okay, for PA intersect B intersect C, we just have we just have 2, 2, 4, 4, and 6, 6. 6, 2 is not. Okay, 2, 2, 4, 4, 6, 6. Here also we have 2, 2, 4, 4, 6, 6. At PB, we have 2, 2, 4, 4, 6, 6. This is wrong. Okay, so we just have 3 elements only. That's mean here is 3 over 36 is equal to 1 over 12. Okay, let's check. Okay, PA times PB times PC. That we get 1 over 12. Okay, PA is equal to 1 over 2. PB, okay, I write here, PA is equal to 1 over 2. PB is equal to 1 over 2. And PC is equal to 1 over 6. So when I multiply, I will have 1 over 24. Okay, that means 1 over 12 is not equal to 1 over 24. That means PA intersect B intersect C is not equal to PA times PB times PC. Hence, this is not independent. Okay? Alright, how about we try for this example? Okay. A consumer research organization has studied the service under warranty provided by the 50 new car dealers in a certain city, and its findings are summarized in the following table. So we have a business that are more than 10 years, so we have and less than 10 years. Okay, we have a good service under warranty and provide a poor service under warranty. Okay, so number one, if a person randomly selects one of these new car dealers, what is the probability that he or she gets one who provides good service under warranty? Okay, that's mean it's not mentioned to us whether this is more than 10 years or less than 10 years. Okay, the question just asks for good service under warranty. So for number one is 16 plus 10 divided by 50 is equal to 26 over 50, or in a smallest fraction I will have 13 over 25. Okay. Alright, so number two, if a person randomly selects one of the dealers who has been in business for 10 years, this one 10 years or more, what is the probability that he or she gets one who provide good service under warranty? Okay, so for this one, the question asks you to find probability. Okay, probability for good service under warranty given with 10 years or more. Okay, many students confuse this one. Okay, why this question is not P probability G intersect with T. Okay, for D intersect with T, we have a keyword. The keyword is N. But the question in this question, no word N. That means we are going to find P good service given a warranty that more than 10 years. Okay, so let's check. Good service. Okay, good service. We have here this one. Good service under warranty is 16. Divide by more than 10 years. Okay, total for more than 10 years is equal to 20. So 16 over 20. So in a smallest form, I will have 4 over 5. Okay, so this is for number 2. Okay, make sure you understand between what we call G intersect T and G given T. Okay, continue with number 3. What is the probability that one of the dealers who has been in business less than 10 years will provide good service under warranty? So the question asks is probability for good service under warranty. Okay, good service under warranty given by dealers who less than 10 years. So good service under warranty less than 10 years, that's mean P prime. Okay, so good 10 here, less than 10 years, so total 10 20 is equal to 30. So we have a 30. 10 over 30 is equal to 1 over 3. Okay, for this example, actually, you can transform it in what we call a tree diagram. Okay, so let's start with the diagram. Okay, the first one, this is for more than 10 years, so T. Less than 10 years is a T prime. Okay, so for more than 10 years, total is equal to 20. So 20 over 50 is equal to 0.4 here. For T prime, okay, less than 10 years, we have 30. So 30 over 50 is equal to 0.6. Okay, and then we start with the more than 10 years. Okay, for good service, okay, G. Okay, poor service, G prime. Okay, so for good service for more than 10 years, we have 16. So 16 over 20 is equal to 0.8 here. And for poor service, 0.2. Alright, how about less than 10 years? Okay, good service, poor service. Okay, for good service, we have a 10. 10 over 3, 30 is equal to, we have 1 over 3 here. Okay, and for poor service, we have 2 over 3. Then this is a probability for T. This is a probability for T prime. Okay, for this one, okay, this is probability for G given T. And this one is probability for G given T prime. This is probability for G given T prime. This is not sorry, this is G prime and T. So this one, the next one is G given T prime, and the last one, probability G prime given T prime. Okay, so actually, from here, we can find P, G intersect T by using formula PG multiply with P, P given, this is, sorry, okay, we are going, actually, we can find probability for T intersect with G is equal to probability for T multiply with probability G given T. Okay, so here PT is equal to 0.4 multiply G prime T, G given T is equal to 0.8. So you can have answer. Or actually, okay, by using this question number 2, we are going to find G given T. Okay, so actually, if by not using any formula, we can directly get the answer from the tree diagram. The same here, okay, we are going to find G given T prime. So G given T prime is 1 over 3, this one. So actually, uh, you can find your answer whether directly by using the table, or you can transform the table to the tree diagram, and from the tree diagram you can find the answer. So it's up to you actually which one is easy for you to solve. See, let's try this example. A mail order house employs 3 stocks clerks UVW who pull items from shelf and assemble them for subsequent verification and packaging. You make a mistake in an order 1 time in 100. That means you makes mistake 1/100. Okay, while V make a mistake 5 times in 100, so 5/100, and W make a mistake 3 times/100. So if U, V, and W fill respectively 30, 40, 30% of all orders, what are the probabilities that A mistake will be made in order? If a mistake is made in an order, the order was filled by U. And if a mistake is made in an order, the order was filled by V. Okay, so for question 2 and 3, the question asks you to find probability for U given M. Okay, if a mistake is made in order, so given M, the order was filled by U, so PU given M. So how about number 3? The question asks us to find if a mistake is made in order, the order was filled by V. That means given V, probability V given M. Okay. So for this example, I will transform it into the tree diagram. Okay, so the solution is in the next slide. Okay, so this is my tree diagram for the example. Okay, so firstly, for the first stage, okay, we have UVW, so where U fill 30 order over 100, so 0.3. Probability for V is 0.4, and probability for W is 0.3. And also mention also to us that you made a mistake 1/100. That means probability for M given you is 0.01. While probability for M prime not doing a mistake, okay, given you is 0.09. So you can find the answer for V, W, and also W. Okay, so if I multiply PU and PM given you, this one, PU multiply with PM given you, we have 0.003. This one is a P probability for U intersect with M. Okay, the same goes to the next one. This is a probability for U intersect with M prime. Okay, and so on. Okay, so the first question, the question asks us to find a mistake be made in order. And it's not told us mistake by U, by V, or by W. Okay, it just said mistake. That means we need to consider everything. Mistake from U, mistake from V, and mistake from W. Okay, so probability that doing mistake is equal to probability U multiply with probability MU given U plus, okay, from V, that means probability V multiply probability MV given V plus probability from W, okay, multiply with P MW given W. Okay, so U multiply with MU given U, we have this one 0.003. And then plus the next one 0.02, this one, and the last one 0.009. Okay, so probability that doing mistake by the tree VUVW is equal to 0.0320. Okay, let's move to the second question. Okay, second question asks us to find probability for U given M. Okay, and if we refer to our tree diagram, there is no U given M. The thing that we have is M given U, M given V, M given W. So how to find U given MU? This is what we call Bayes' theorem, inverse. Okay, so how to find U MU by using Bayes' theorem? So the formula is probability for U multiply with probability MU given U divide by total mistake. That means probability M. This one we already calculate from the question number one. Okay, so PU multiply with PM given you. We already have here. Here. 0.003. So divide by total mistake. We already calculate from number one. 0.032. So the answer is, so I will have 3 over 32. Or in a fraction, I will have 0.9375 in decimal. Okay, so this is for number 2. So the same goes with number 3. Okay, number 3 asks us to find PV given M. Okay, and if we refer to our tree diagram, there is no V given M. The thing that we have is M given V. So this is Bayes' theorem. So by using the formula, okay, PV multiply with PM given V divided by PM. Okay, so PV given multiply PM given V, we already have here 0.02 divide by total doing mistake from number 1 is 0.032. Oh, so we will have, okay, 5 over 8, or I can write as 0.625. Okay, so this is about Bayes' theorem. So we already come to the end for this topic, and it's a very quiet long topic. So I hope everybody can understand my explanation. Okay, so all the best and thank you guys. Assalamualaikum.